Humans on this planet, we have glorified our intelligence for the longest time. We see ourselves at the top of the food chain, at the very top of reality among all the animals, insects, species, and creatures. We alone have the highest intelligence. And in this coming era of AI, that may remain true. We are at the very pinnacle and peak of intelligence, as far as we know. As far as we know from a biological standpoint. For we have yet to establish, is there consciousness beyond what we have experienced as human beings? We have yet to truly explore that and validate that for certain. What we have accepted and agreed upon, at least in the developed world and developed areas of this planet, whether that be the cities and organized societies in Africa, Asia, Latin America, parts of Russia, and the Americas, that we've agreed upon that science deals with what we can say for certain, largely that which is physical, that which we can verify. That is what we can all agree upon. And so our science is based on the physical things that we can touch, feel, see, hear, and directly experience in a way that can be described such that others can experience it, test it out, and validate it in the same way. That's how our technology works. So, AI has caused quite a stir among people, because on a certain level, it challenges the notion of intelligence supremacy, intellectual supremacy. And I would say that we shouldn't get so uptight about that for a variety of reasons. So apparently there are these crows that was discovered some while back that they have a very specific way, not specific, but they have a very curious way of getting food, or getting at food, should we say. And they basically can take a stick or a leaf that is attached to a stem and take the leaf off and use the stick like a pole, like a spear, like a single prong fork, right? And I thought it was real interesting how these birds, these crows, were able to use a stick to pull out food. You know, there are some gorillas, I think, that does something very similar with ants. But in this case, the crow is attempting to get a worm out of the hole. And normally, the crow would, or any bird with a long enough beak, would still have a challenge trying to get the worm out of the hole. But through the use of a tool and intelligence, the crow is able to make something work that normally wouldn't work with just its body and biology alone. It's a nice little challenge. Can these crows actually get food out of a container, out of a man-made container? As far as I know, and I haven't researched this deeply, these are not lab-grown crows, and these are not trained or extensively trained crows. I'm operating under the assumption that these crows have not been trained by these researchers to do the things that they can do. My assumption here is these are natural crows using natural intelligence to attempt to get something they find very desirable. In this case, a worm at the bottom of a cylinder, a cylindrical object. And as I watched this, I was like, okay, I could understand using a stick to get a worm out of a hole in a tree branch. But, if these crows are as intelligent as these researchers are suggesting, then they can simply observe and make reasonable conclusions about different things in their environment. In this case, a lever to release a worm that they want to consume, right? So then there was another part to this that I thought was really interesting, where the crows now knew that there was definitely a worm at the bottom that they wanted to get, but there's no lever here, right? So how are they going to get the worm? Their beak can't fit all the way down that cylindrical object. So took a rock, pushed down the bottom so they could get at the worm. And I was like, you got to be kidding me. But to the extent that this is a legitimate situation that we're observing with a natural creature that did not go through human school systems and human education, they nonetheless was able to achieve their objective. And then you have, this looks like a parrot to me, that was sneaking in here, and late at night they were able to open up a canister of butter. The canister of butter is sitting down there at the bottom. And I did not know how the bird was going to get in here, but then it became obvious. It started with the cat. It always starts with the cats, don't it? Whether it's toxoplasma in ancient Egypt or a can of butter in some far-off cafe somewhere in Australia. And so then this bird saw how to get in by, I guess, watching the cat, and got over there, found an opening. And I actually don't remember if birds have a sense of smell, but I'm like, it found its way to the food. And you never know if these situations are contrived in some way, but taking it at face value, I mean, this bird went and got it a source of fat, because fat is a very vital energy source. And there you have it. There you have it. Intelligence all around us. And that's not the first time I had seen something like that. I remember the first time I learned about a species of monkeys that used rocks and whatever they could. They used rocks like hammers to crack open the shells of certain nuts. And it turns out that humans are not the only ones that likes pistachios, cashews, and peanuts. And there are other creatures out there that absolutely love peanuts in their varieties as much as humans do. So, it turns out that intelligence is something that permeates all of reality, from insects to birds to reptiles to monkeys as well as humans. So when people talk about artificial intelligence as this entity to be avoided, I have realized that that is some very alarmist thinking. That is some very premature reaction to a tool that can change lives, that can improve a person's condition in this world. And I know that there are people that are suspicious about corporations, suspicious about the government, suspicious about religions, and suspicious about what we have been taught in schools. But I think it is helpful to realize that suspicions are not always 100% valid. And something can be partially true and still be useful, but the other side of it can be just as valid. And so balance is about finding that unity, that harmony, where you can navigate this world carefully while at the same time making good use of those things that would provide us extraordinary benefit. Let me be more clear. You can watch all the conspiracy theories you want that tells you to avoid AI and avoid different tools in what is called the system all you want. And I predict that you're going to find that 20 years from now, 20 years of avoidance while you're still alive means that you're that further behind. All because your suspicion meter was jacked up on high. And so it is time to be smart about the technologies and about the tools. So that's my philosophical beginning of this conversation. But what I'm really here to talk about is vibe coding. So let's look at vibe coding from the standpoint of someone that has a very significant amount of experience in software development and what they have to say about this topic of vibe coding.
Karpathy, an OpenAI founder and formerly head of AI at Tesla, introduced a new term for a style of programming with AI assistance. He called it vibe coding. Now, I'm no stranger to the ideas of too long didn't read and semantic diffusion, but I think that this might have been some kind of record. This was a 1,000-character tweet, and it seemed that few people even got to the second half. Andrej describes what he means by vibe coding in the first 300 or so characters of a 1,000-character tweet. The rest describes some of the consequences of this naive toy town approach to programming. Now, I don't know Andrej personally, so I can't tell what he had in mind with his tweet. But it reads to me as sarcasm. Near the end of the tweet, he says, "It's not too bad for throwaway weekend projects, but it's not really coding. I just see stuff, say stuff, run stuff, and copy and paste stuff. And mostly it works." So I think that vibe coding is at least up for the prize of the worst software idea of the year so far. Nevertheless, it seems to have gone viral and now is a well-known phrase in our domain. And so that's our topic for today.
Every generation of software developers says that the software development done by programmers 3 or 4 generations removed is not real software development, and that the languages are toy languages. When I started doing software development, I was using a language called GW Basic, and then I evolved from there into a language called Visual Basic. In between, I had languages like Perl and JavaScript and others, but my next major language after GW Basic was Visual Basic. I remember the C++ developers at the time saying that Visual Basic is a toy language. And I understand that perhaps at some point, some of the assembler programmers way back when would have considered C++ to be somewhat of a toy language. And then you have the many developers that use languages like Java and C# that may have at one point called JavaScript a toy language. So these descriptions of toy languages and what programming really is quite subjective. Let's keep that in mind. That's not to discount the main points that he expresses in this discussion, but we have to keep in mind that we all have biases. And can we occasionally go beyond those biases to see the core truth?
For industry, the idea that writing code is the hard part. Non-technical people believe this is true because code looks so complex and mysterious to them. Developers believe that it's true because code is comforting and precious to them and clearly defines their skills and separates them from the non-technical people who presumably aren't as smart because they can't read the code. We've built a technical recruitment industry on this premise that the defining characteristic of a good programmer is the set of languages and frameworks that they know. We have people who define their jobs by the tools that they use. I'm a Java programmer, I'm a React developer, and so on. I've admitted before that I have hired programmers who haven't used the same technology that we were using on a project, and I've never regretted that so far. In my experience, you can learn a programming language if you're good at programming, enough to get by with it in a few days, maybe a couple of weeks. Doing software development well is hard, very hard, but the difficulty is not created by programming languages.
I disagree with the conclusion that software development difficulty is not a function of the programming language. The programming language is not the only difficult part of software development, but it is an element of that. The counterpoint to what he has said is that there has been articles written for just about as long as software development has been around, since the 1950s, about the impact of the programming language on programmer productivity and a programmer's ability to leverage the programming system. So, I myself have written articles that go by the title of "Why is C++ so hard?" I did not find C++ hard, but I have known many people that have. And I wrote an article like that on Quora that explained, from my point of view, why many people found C++ to be difficult. There are thousands of software developers over the years that would immediately say that C++ is more difficult than it needs to be, and that you cannot write programs as easily in C++ as you can Visual Basic, Java, C#, JavaScript, or Python. This is why Python programmers, C# programmers, and Java programmers outnumber C++ programmers. The fact that you have programmers in various languages to greater or lesser magnitudes based on perceived difficulty as well as experienced difficulties speaks to the idea that the structure and definition of a language influences the ease with which someone typically engages the software development process. A large part of Microsoft's business with software developers hinges on this concept of making software development easier. The huge growth we're seeing in AI and software development is in part based on this concept of streamlining the software development process so that developers are not engaging with boilerplate code. Many of those boilerplate codes have to be formulated through languages that, when they are defined to be more difficult or conceived to be more difficult, becomes a disincentive to even want to pursue the boilerplate code on the way to the actual solution. So his description of a programming language is not an ingredient in software development difficulty is not founded by both the anecdotal as well as research that exists on programming, where even universities have found some issues with that. And some of that, I believe, is the University of Edinburgh, if I've said that correctly, that found that when software developers anthropomorphize software languages and programming and computers, that the difficulty can often increase, and I would add, in concert with the perceived difficulty of the language itself.
We can give in to the vibes and forget that the code even exists. Well, the other group of people that do that are the sometimes non-technical people who want to achieve something via a computer. Up to now, though, we human programmers have played the role of the coding assistant in this conversation, translating what it is that they want into something that works. So how well does that usually go? Not so well, I'd argue. Certainly very poorly for any software of any size or complexity. This often goes very poorly indeed. And so far, we humans are still smarter than the machines. This isn't because it's so difficult to translate what people want into a programming language. It's because it's so hard to break problems down into the precise deterministic instructions that, LLM or not, are still how computers ultimately work.
I sincerely disagree with the point that the difficulty in software development is concentrated in how well you can break down problems. And again, these are not disagreements that I have pulled out of the air. I have spent years having discussions about this in forums like Quora, where I've discussed this at length with other technology professionals and researchers. And so my analysis, based on my experience with software development, not only as an individual contributor, but also one who has mentored and led teams and mentored individuals who are brand new graduates from university, is that being able to define and deconstruct a problem space in software development is valuable, yet you have a parallel problem that exists when you are doing software development, and that is maintaining fluency in real time with the syntax, structure, and conceptual layers of the language and technology frameworks that you're using. For if you misunderstand or underappreciate the tools available to you, then you will increase the difficulty with which you can solve these problems. So I think that the insights he is expressing comes from a good place, but they come from a place of wanting to oversimplify or wanting to make the the situation more accessible. And we can lose resolution. We can lose accuracy in what we are trying to convey when we oversimplify something that is inherently complex. And software development is inherently complex. And our expertise can create blind spots where we think that because we have overcome certain aspects in our day-to-day, those issues still are there. We're just simply more accomplished in mitigating them. That we have now summarized what you need to do to be more effective as the solution that should be projected onto everyone else and the problem space at large. In this case, he has reduced it down in his experience to the ability to deconstruct, or what you would call the deconstructive method of software development, where you just break things down into problems and subsets that when you can solve those subsets, then those subsets become the foundation for the layers that follow on from that, right? And that's how you build reliability. But as you're doing that, those that are more junior in software development or those that are entering a different space altogether, both in terms of technology tools and the actual business or operational domain, we'll find that the collection of elements and ingredients in the pursuit of developing a software product solution all play a part in terms of their difficulty that has to be managed. So that's why I disagree with the point that he raised, that it is just about solving problems. It is more than that. It is far more than that.
If you look at programs from years ago and modern programs, there's something kind of weird going on. There's seemingly a persistence, a consistency to the level of detail that we need to express to make a working program. And that's been true for decades. However we encode the level of detail that we need to define, it's pretty consistent. Programming languages aren't strange because of some fashion or masochistic trait in programmers. They are tools that have evolved to be good at expressing an idea clearly and with the required level of precision to achieve an outcome from the box of billions of switches that make up a modern computing device. Programming languages aren't more complex than real-world human languages. They're simpler, more strictly constrained, and more precise. That's to our advantage in trying to achieve our goals when programming. Programming languages are tools that are designed to help us to structure our thinking, so that we can decompose problems into the steps that are necessary to achieve the outcomes that we are striving for. So the idea that we can do better if we adopt a vague, imprecise, expressive richness that's in human languages to precisely define behaviors in a computer seems to be very far from the truth and missing the point almost entirely to me. So vibe coding is not even close to being the right answer, really. Another example of humans attempting to achieve clarity and precision with natural language is the law. And if you've ever had to read any legal document for any purpose at all, I think you'll agree with me that this is not really what we might hope for in terms of clarity.
Now I find something with which I can agree with him on, with some caveats. Let me start with my caveats before I look at what I fully agree on. The caveat is that he earlier said that programming languages are simpler compared to human languages. And by that, I would take that to mean in terms of the number of words and the grammar itself. The thing to be careful with there is that relative simplicity is not the same as overall simplicity, right? So something may be simpler than something else does not change the fact that that thing that is simpler is still in and of itself complex. So anyone who's ever written programs in Lisp, Haskell, or F Sharp or OCaml can attest to how even a simpler functional programming language may challenge those that are more inclined towards more structured imperative programming languages such as C, C++, C Sharp, Java, JavaScript, and Python, right? And so just because something is simpler, relatively speaking, does not mean that it is simple overall. It is complex on its own terms, right? And by saying that programming languages are simpler than human languages can subtly lead you to thinking that because they are simpler than human languages or simpler than human written language, that then that means that they're going to be simpler to use, or they're going to make software development simpler and easier. And that's the cognitive trap that we have to watch out for in this. So that's my caveat. Where I fully agree is that human language is richer and far more multidimensional than the computer-based programming languages. Computer-based programming languages are very linear and generally one-dimensional, whereas a human word can have multiple meanings, multiple contexts, and can map to various threads of human history, culture, subjective preferences, and a litany of things that the human mind is very adept and expert in being able to piece together, even when a given human speaker is able to formulate new combinations that have not been formulated together, such as in rap music, hip hop, or just everyday slang. And when you go into formal language, even new words that are introduced that were previously not in the dictionary but became accepted as part of the overall human language because those words fit the context somehow, maybe by way of the etymological components that have historical precedents that relate to the new context in which the newly formulated word has been integrated. So, on that basis, yes, because of the wide variation and the wider utility of human language would not, in and of itself, human cultural language and human verbal language would not, in its present forms, be adequate or effective in developing software programs the way that we have, because software development it evolved out of mathematics, and mathematics is very precise. Arithmetic is very precise. 1 + 1 is going to equal 2. And even if you decide to go with Terrence Howard's particular interpretation, we're still talking about a formalism that is widely agreed upon, that has no ambiguity to it. Whereas languages outside of mathematics, where we're talking about feelings and situations and total experience, much of which cannot be accessed physically, then there is no translation from that into a software program that exists as a fundamental physical entity in an actual physical machine. So, on that point, I certainly agree. And I have to expound on that too for my own sake, because once upon a time, during this whole this present era of AI, because I was also part of an earlier era of AI that I won't go into here. But in this present era of AI, I had reached a conclusion that if you master human language, then that is the new programming model for the future. And through my experiments with ChatGPT over the last 2.5 years, I found that concept is false. It is inaccurate. And that will be more fully revealed in this discussion.
To me. So vibe coding is not even close to being the right answer, really. Another example of humans attempting to achieve clarity and precision with natural language is the law. And if you've ever had to read any legal document for any purpose at all, I think you'll agree with me that this is not really what we might hope for in terms of clarity and precision. We can think of the act of programming from a variety of different perspectives. I'm sure that the most common way to think of this is probably to think of the act of writing code in a programming language. But I am somewhat skeptical of the utility of this. It's rather like defining a plumber in terms of their use of a wrench. There's more to it than that. And the things beyond the syntax and organization of code are more interesting and more complicated parts of programming. The shapes that we paint with the code and the outcomes we achieve with it are both more interesting and more useful than the code itself. I think that ultimately there are three goals for programming languages that really matter. One, to help us to organize our thinking about a problem. Two, to communicate our understanding to other humans. And three, to tell a computer what we want it to do. Each of these is important to the act of programming and represent different levels of value in the programs that we write. The hardest part of programming seems to me understanding the problem that we're faced with in enough detail that we can see that whatever we come up with is likely to make a good solution. Programming languages solve this problem by giving us tools to constrain our thinking in ways that help us to compartmentalize our picture of the solution that we're aiming for so that we can scope it and manage the complexity of it. They allow us to deal with parts of the problem separately from other parts, using techniques like modularity, cohesion, separation of concerns, abstraction, and managed coupling. This kind of thinking about writing programs is a mix of programming language constructs that help us to build these structures into our code and our innate knowledge and understanding of design that we build up from experience. Programming languages can help to steer our thinking via their design, and the rest then is down to us. A big problem for us as programmers and for large language models as programmers is that we need to learn to apply some sense of good taste in our design choices.
As Lord Belim said in Jupiter Ascending, stop. So there are some issues there, and this is where we have an actual split in the software development community at a high level. There's an actual split. And this split is not something that's recent. This split probably started, probably around the 1980s, maybe the early 2000s. But you have the programmers on the one side that looks at software development as a overall process, architecture, design, high-level concepts, right? And then you have the software developers that look at things from the standpoint of code, actual technical fluency, technical expertise, and detail, and mastery of the technology and the computing construct. So you got two different points of view. And if anyone wants to know through this conversation or conversations like this why software development looks the way it does is that it is not a unified field of work, or it's not a unified group of people. You got different camps. It's not a unified group. The hardcore programmers, the technical masters and specialists and experts who look at it more at the standpoint of, let's really manage this machine, let's manage this computing device. And we still are building product. We're still building solutions. We're still building these things. But let's build them with great artistry, mastery, detail, reliability, sophistication. And that's where you get things like Linux, LibreOffice. That's where you get things like iOS and macOS and so on, right? Whereas on the other side, you have those that look at things from a high-level process standpoint. It's more administrative. It's more architectural. It's more in the clouds. And that's not even a pun. But before there were the clouds, there was the cloud-minded thinking. Some would call them, what did Joel Splosky call them? Architecture astronauts, right? And that was a term that applied more to the Java programmers of yesteryear, but it has expanded out since then. And what camp am I in? I'm actually in both camps, believe it or not, and I can see both points of view. But if I had to choose, I'm going to choose that group that deals with technical mastery and deals with the practical aspects of writing software. Because I look at it from a couple of different standpoints. Number one, you can have all of the paradigms and you can have all of the beautiful and elegant methodologies and concepts in the world. You can have good software development process from a management standpoint all day long. But if you can't write that code properly, and if you don't understand that machine, you're not going to get anything. I can rediscover software process, but I cannot rediscover software development mastery at the ground level in time enough to make a real positive impact on both the business as well as the end users. So when we see these advocates for software development on procedural grounds talk about how breaking down the problem is the most important thing, and that subordinates all the other aspects of being able to communicate to other people as well as really manage the machine, control the machine. That actually takes us far away from actual software development and into some other space that really doesn't serve us well long term. And so, but let me just say that it is still important that you have process, that you have standards, that you have controls, and you have the other elements that are conceptual, that are in the clouds. I believe in those things. But they are actually less important than the actual technical mastery at the end of the day. And when we look at it from that standpoint, technical mastery, then we see what the issue is with what is being called vibe coding, right? And yet, I am not saying vibe coding is bad. Like I said, this full discussion is going to really look at vibe coding in a clearer way, but we have to walk through where the software industry is now in terms of its perspective and why much of this tends to appear to be unresolved.
Taste in our design choices to make effective use of these language constructs. And we've all seen enough counterexamples to know that not everyone does that. But our poor large language models have been trained on all the code. The good, the bad, and the ugly. And unfortunately, there's more bad and ugly out there than there is good. And we as a profession have also not been very good at defining what good really looks like, to differentiate it from the bad and the ugly. If you ask 10 programmers to tell you one thing that makes the difference between good code and bad, you'll probably get 15 different answers. This means that large language models are probably not going to have a great sense of what makes good code from their training data. So we either have to tell them or accept them creating bad code. And to be fair, this is all rather complex and nuanced, because what makes great code in one context may be too simple or might be overkill in another. I certainly have my own set of defaults, and my book is an attempt to define some generic cornerstone ideas that I think are general enough to help. But even then, it's still contextual. My background and experience has led me to a reasonably defensive evolutionary approach to design and development. I think that the strongest mental approach is to assume that our guesses, whatever they might be, are probably wrong, and so work in ways that allow us to correct. A meaningful measure of quality in our code then is our ability to change it. So I always strive for the simplest, easiest to read, easiest to change solution that I can find. But what does ease of change really mean when a large language model rewrites all of the code from scratch nearly every time?
All right, so there are two major pieces there that we have to unpack. The first one is that the software development industry at large has not defined what good code is. Anyone who's ever looked for a job in software development knows that that is absolutely false. Anyone who has participated in software development forums between, I would say, 2010 and 2020 knows that that is false, because the software development industry, I would say around 2005 through 2010, absolutely rallied around best practices that has entered the vernacular of software developers. Is that still true? I don't know, but I know it was true for the longest time. And we had concepts such as Agile and the Agile methodology. We had, I believe his name is Robert C. Martin's clean code that influenced thousands upon thousands of software developers. We had Robert Fowler's patterns of enterprise architecture and refactoring that influences thousands upon thousands of developers, as well as tools like Visual Studio that has a refactoring menu item on it. We have solid principles. We have DRY, don't repeat yourself. We have tons of best practices. And even before 2005, I was reading books like Component-Based Software Engineering. And I think the guy's his last name was Siegel. He wrote various editions of Component-Based Software Engineering. It was a thick book, and it had a wealth of information on actual engineering of software as opposed to just writing the code ad hoc. So he is incorrect that the software engineering community has not defined best practices. So there is an avalanche of knowledge and written books. The Art of Computer Programming by Dr. Donald Knuth. There's so much information on best practices and how to write good code that it fills up pretty much an entire library at this point. And so where he is correct is that there isn't one single way that software developers have to write good code. But the way he worded it, it implies that there are no good ways to do that, that are significant. There are significant schools of thought around software development that goes all the way back to the origin of COBOL, or the years following the origin of COBOL, Waterfall methodology. We have the NATO conference on software development or software engineering in the 1950s or 1960s that influenced the development of standards around software development. So I understand where he's coming from. He's looking at the noise, the chatter that's out there where developers get into debates about best practices. But that noise is not the actual signal that exists, that there is a body of knowledge about good software development practices. As far as writing code, there are some general principles that most agree upon. And we have the gentleman that I used to know his name off the tip of my tongue, but the gentleman that convinced everybody to stop using the Goto keyword in programming languages, the gentleman who, is his name Professor Hoare? I'm not sure. But he convinced people to do what's called structured programming. And structured programming is now the core baseline in your programming languages. And so there is a minimum acceptable standard in writing code that permeates all imperative programming languages such as C, C++, Java, Python, JavaScript, and others that are very similar to those, including Kotlin and Go, as well as Visual Basic and Basic. So that is not true what he was saying about good code doesn't exist in terms of a template, in terms of a structure. What he has accurately described is that the large language models has been trained on bad code, middling code, as well as pristine code. The bad code on the internet does outnumber the good code that is on the internet. And that's because the majority of the good code is either locked up in corporations who have not exposed their code to the internet, or the good code that does exists in open source projects that are written in programming languages that are not as widely used. So you may have superior code defined in Java, C++, or the C programming languages. But because the majority of programmers these days are using Python and JavaScript, the translation from C, C++, and Java into JavaScript and Python is not going to happen very effectively. So that's going to be an issue there. The second major issue that I see in what he has discussed is how good software development is about making the code as simple as you can. And this is an idea that doesn't have real grounding in reality. With certain software applications, what we would call CRUD apps, C-R-U-D, CRUD apps for your regular business applications, there is more of an emphasis on making that type of code simple. But you do not see the simplicity mandate represented by certain projects like those in the FANG, what they would call the FANG companies. I would suspect that Google, for some of the things that they have to develop that deal with very complex networking applications, there are many instances where the code cannot be simple by the standards of someone that's working in the IT department of a small business, small or mid-sized business, right? So the two types of coding environments or technical situations, because they're not equivalent, what is simple at Google would be considered complex at a smaller IT organization, right? So the same at Meta, the same at Microsoft. What would be considered simple there in terms of like a simple data structure implementation would be considered overkill in building a general purpose website for keeping track of accounts payables and receivables for a small customer service company. So that's some of the insights there. That leads us to the opportunities that we see here. The opportunities in our own personal use, either as individuals or as organizations, in the application of large language models, AI. And that is to actually build up our own curated databases that the AI would then use to be able to more effectively develop software on our behalf or as an assistant to us in us actually driving the software development process. So that's the opportunity that exists there. That is what is not presently encoded in the AIs. That curated, that custom fashioned database of best practices and only the best practices, right? You can do this in ChatGPT. I have done it. You can do this in ChatGPT. But it takes labor, it takes time, it takes effort. And, so when you don't do that, when you don't pursue that course, then you're using AI in a very laissez-faire fashion, in a very laid back, in a very casual fashion. That's the vibe in vibe coding. But once you address the data issue in the large language model, then everything that people are saying as far as the detractors or the objections to using AI in software development, that starts to evaporate almost instantly.
That all the code is now equally easy to change? Well, not really. The code's only easy to change if we can also determine that after each change, however big or small, it still does everything that it's supposed to. But how can we determine that unless we specify it in detail precisely what our system is meant to do? For humans, this sense of what is it meant to do is often implicit. It isn't usually written into the code. But for AI-generated code, that's an even bigger problem. I think there are three big problems that the use of AI in programming highlights for us. How do we specify what it is that we want with any degree of precision? How do we confirm that we got what we wanted? And how do we retain our ability to make measurable progress in small controlled steps? The first problem goes to the vagueness and imprecision of natural language. The second highlights the even more important role of automated testing for code written by an AI. And the third is about another quite deep problem, the profound difference between the way that machines write code and the way that we humans do. Fundamentally, this matters because of our ability to reliably reproduce a result. All successful systems evolve over time. That means that we need to be able to change them when our circumstances or our understanding changes. Humans who are good at building complex systems do so by compartmentalizing the problems so that they can retain their ability to make change safely in one part of the system without those changes leaking out into other parts of the system. This is true in physical engineering as well as software engineering, and it results in all complex systems being built in this sequence of small changes, however we organize the building of them. So my idea that the definition of high quality in software is defined by how easy it is to change is, I think, rather important, because we must nearly always be able to change it. This highlights the importance of ideas like continuous integration and continuous delivery for building complex software systems. To me, this is independent of whether or not we use AIs to write the code. AIs, though, don't write code the way that we do. Most of them generate the code from scratch, often after every small change. Ironically, this same problem, ignoring the importance and ability to revisit and correct or enhance code, has been the stumbling block that has seen off every other attempt at raising the level of abstraction in programming, from 4GLs and model-driven development in the 1990s to low-code and no-code systems now. They are all built on the assumption that the code would be right first time and wouldn't need correcting, and so round-tripping the ability to go back to existing code and correct or enhance it was difficult, if not impossible. Many of these attempts were not even version controllable, and we seem to be in danger of making the same mistake yet again with AI programming. Ignoring the problem of being able to update the code is stupid, because it relies on us and the world being perfect, and neither of us are. AI has this problem, and it doesn't at the same time. If it can recreate even complex software from scratch given some instructions, then do we still really need incrementalism? I think there are two answers to this, but neither line up with well with vibe coding.
Many would know about the idea of the mathematical proof in software development, where if you were to develop the right mathematical structure for a software program, that you would be able to produce a program that you could both verify in its entirety and one that would run, for all intents and purposes, flawlessly. So that idea has remained elusive for the majority of software programs out there, at least in large part. There are some aspects of that we see in compilers, that we see in very advanced software libraries, and I am sure that those that build actual large language models themselves, the actual technology behind the large language models, the transformer models, how it's written in C and C++, that they have some deterministic proofs that they can apply there. But by and large, for the software development that the majority do, building CRUD apps, building websites, web applications, mobile apps, and a variety of back-end processes and microservices, that these sort of concepts do not apply. So what we have here is an agreement with what he has said about this, where it's like, okay, so we see that you do have to regenerate software on a regular basis. When you make changes to software, that you're going to end up with a new version of that software that incorporates both the previous changes or the previous state of that program and any modifications that you've made since then. So he is correct about version control, that you want the ability to track these changes so that if your assumptions about the new modifications turned out to be dramatically incorrect or simply subjectively undesirable, that you could easily revert back to the previous state as you try to figure out how to move on from there. So the large language models don't handle that particular process quite well. And I think ChatGPT's Codex is an attempt to approach that. And so we do see that there are some deficiencies with using large language models in software development. We know that the mastery at the hands-on level in software development is vitally important and will remain important for the entirety of software development. I'm not even talking about 5 years, 10 years, 20 years. I'm talking about 50, 100 years. Because there is something essentially hands-on about software development. Large language models and AI, when you attempt to use them to replace software developers, produce things that you don't like, things that you don't desire, security issues, unreliable software, broken systems. And humans can do the same thing. Humans can make bad software just as easily as AI. But the right humans, the ones with the right process and the ones with the right understanding of the hands-on, ground level execution of software development, they can use AI all day long and use it in ways that produce great end results. So that's where I think the consensus is that vibe coding, as it's described as a full-on replacement for expertise, is a dead end. But there is some indications, there is some opportunities there to use AI to accelerate the experts, to enhance the experts. And as the experts are enhanced, then what they uncover, discover, and find out can be then encoded both in documents, web articles, YouTube videos, social media, whatever. And then other developers who slide into the use of AI tools in the way that the experts use them would then begin to see similar benefits. And that's how all the tools and best practices prior to AI evolved. It evolved in just that way. Software development was never defined by the junior developers. It was always defined by the senior experts, and the expertise trickled on down. In the past, it was primarily through books and one-on-one mentorships. And then that evolved into conferences and articles and a variety of expertise baked into the tools themselves, like Visual Studio and others. And so then you moved on from there, and you are now where we're at presently, with now trying to bring this tool into the best practices of software development. So that's how this is going to unfold. And the discussion would end there, but there's a new idea that's coming up that is going to create some challenges, but also some opportunities.
Line up with vibe coding. If I, as a human programmer, build a complex system, complex enough so that I can't hold every last detail of what I want and what I did in my head, and now I want to make a small change to it without breaking things, I can only be confident in my ability to do that in two ways. I can test everything and then run all my tests again later to confirm that they still pass, or I can design my system in ways that allow me to change code in one place without worrying too much about what may happen elsewhere. But that second approach is foundationally built on the assumption of deterministic incrementalism in execution and design. Can I be confident that my compiler or language will interpret the code that I didn't change in exactly the same way as it did last time? Can I be equally confident that my AI can do the same? What do I version control to achieve this? What can I version control to achieve this? If I can do this, I only have to worry if my new change is correct, and the isolation between the old code and the new code is good enough for me to rely on. But if I can't, I'm lost. If the AI regenerates all the code from scratch every time, or does that occasionally, or is learning new things and so changes how it interprets my instructions, then I can no longer trust it to recreate something that works as it did before. So I need to check that it does. This makes automated testing, continuous integration, and continuous delivery even more important for AI-generated code than it is for human-written code. And this isn't just me saying this. I recently saw an excellent video making the same point from an OpenAI researcher. My point and his point is that the best way to prompt an AI is with an executable specification.
Which I
That is
disagree.
a precise, accurate example that describes exactly how the system that you want to build should behave in clearly defined.
I mean, this has been like a pretty intense
I had already
couple
watched
of
this
days. I don't know
before
if you feel the same way.
I had watched
but
the
also very
previous
energizing.
video. I had
So I want to take a little
watched
bit of
this
your
one
time
first.
today to talk about what I see as the coming of the new code. In particular, specifications.
I was not a fan.
Which sort of hold this promise that has been the dream of the industry, where you can write your code, your intentions.
Save some time here and let you know that I watched this video twice. The first time I watched it simply because I was curious, and the title of the video matched up with what I was already exploring. I had already went through this process many months ago. I already went through this process almost exactly a year ago. It maybe 11 months ago. I went through the same process. I had good results with it, so it does work. But my approach is not exactly the same as their approach. My approach incorporated much more detail about software development itself, not a spec about the program, but a spec about programming. There's the difference. The other issue that I have is that OpenAI has this great idea, but they have not trialed this idea in any significant way with a real world program or programs. So this is basic beta testing that could go horribly wrong for people who try to follow software development in this particular way that they are advocating. The other issue that I ran into when watching this video is that I actually agreed all the way until I got to the very end, when I was like, you know what? You cannot possibly scale this to every software developer. The majority of software developers are not going to spend weeks and months out of their life building a spec, building specs. And I'm not talking about one simple spec. I'm talking about, to make this work really well, you need multiple specs, a hierarchy of specs, and it's going to become complicated developing and managing these specs. And while that is a valuable process in and of itself, one that I'm going to follow myself, because those are things that I do, it's not something that you can expect junior developers to do, or expect your average developer to do when they just want to open up an IDE, a development tool, write the code, get some assistance from the AI, and have a really good output, right? And if we subtract the AI part, for as long as we've been doing software development, software developers have been typing the code and pressing a button or running a script and getting the output program. And that's the core essence of that. And software developers find that to be very accessible and very convenient process. You got feedback loop in there and everything works well. So when you're adding basically an administrative process into software development, and there are already administrative processes in software development, but when you add this particular one, that is traditionally the domain of business analysts and project managers, and you're trying to make every software developer a project manager, you've lost scalability in your software development process. And yes, you can regain some of that lost scalability through agentic programming and through MCP and other approaches that are being pioneered now. But in the short term, you are not going to have gains, and those that are able to leverage the state of the world as it is now in terms of how software development has been, are still going to remain more competitive than those that are doing what we would previously say, trying to reinvent the wheel in such a way where you're gold plating, you're polishing the fine china, but you're not going anywhere fast. So there are some huge pitfalls to watch out for here, and specs as code, specifications are not code, and specifications are not equivalent to code. And when you see that on the surface, you might be inclined to agree that specifications and code are synonymous, but when you dig into the details matter a great deal. And code, the way that we understand it, in the form of assembler, C, C++, COBOL, Fortran, JavaScript, Python, those are very specific grammars and syntaxes for engaging with the computer machine. Specifications don't do that. Specifications is in the human domain, and large language models are in the human domain, right? That's why we like ChatGPT, Google Gemini, Anthropic's Claude, DeepSeek, and all of them. That's why we like all of that, because we are people and we like using tools for people. But when we're talking about programming and software development, we're talking about a machine that has a very specific definition to it, that is very mathematically defined, and the map in between is the programming language. And so large language models are not a map to the machine, right? And that's where specs as code is inerrant and a fallacious point of view. So specs as code, be very careful with that. What I see the benefit for specifications is as another way of refining the overall context of LLM sessions, LLM engagements, right? So if I set up specifications with great granularity and intricacy, right? And I relish the opportunity to do that. But when we set up specifications with great granularity and intricacy and sophistication, then we can better constrain the output of the LLM in the direction we want it to go, right? But the human operator always has some measure of subjective insight into what is being output, right? So unless you are committed to a 100% mathematical provable process in your software development, and you say, okay, if I can prove it mathematically, encode that as a specification, and then the LLM can output that, unless you're willing to go to that extent, then the best that you're going to get from specifications is that you can greatly reduce the amount of error, and you can keep the window of deviation from where you would like the code, how the code should be structured, formatted, and expressed. You can keep the window of deviation very small, so that even when you do have deviations, that you have less work to do. And that's where I'm smiling, right? That's where my smile comes from. How do we ultimately reduce the amount of correction that we have to do when we use the LLM? Now, what I've essentially said in all of this is that in order to take advantage of the LLM effectively, is you are going to have an immense amount of pre-work. This is something where it's really an entirely new industry that I'm entering into, and many are entering into. That is the software development management, where you are basically setting up the managerial and project management infrastructure that makes software development quality increase exponentially, where you're able to take your ideas, express them through AI, have an output that comes out that works really well, but knowing the subjective aspects of software made by people for people, and even if you have a machine working as a proxy for a software developer, making software for people and the processes that ultimately affect people, that there's always going to be elements of subjectivity that has to be addressed, right? And so if we can make that process more efficient, that's really what we have been doing over the course of improving software development over these past decades, is simply working on that particular aspect. So everything that I said in this video, including my disagreements, all work to that end right there. So I hope you've enjoyed this conversation. I know it's been quite a conversation, but if you really like this type of stuff, then this was a conversation that was right up your alley. And I cannot say that I will have another conversation like this. I just had a series of thoughts in my mind. I've incorporated in this video, and even if I get 2 or 3 people to watch this, I think it will be worthwhile. But from now on, when someone asks me, what do you think about AI and software development? What do you think about vibe coding? I'm just going to send them this video link. This video that I just made, this is my dialogue. This is how I make my communications more efficient. I make videos now, and when people ask me complex questions, I can give them a discourse that I've already delivered where all the ideas are there, and I don't have to remember those points, because over time we engage with new concepts and new scenarios and situations, and what we was very engrossed in terms of understanding a situation and a set of concepts and circumstances, it can dramatically drift over time. And so to such an extent where we're like, okay, I once had some immense points of views about this topic, but now I have kind of moved on from that. So once again, that's my view on all of this. And what really got me to switch my point of view, other than the things I said in the previous video, was this one video right here. 6 ways to make money with the new GPT agent. It blew my mind. That's the title of the video. The channel is called the Corner Office Podcast. So what really drew me to this video was the term GPT agent. So I wanted to see how this individual was using a GPT agent, because I've heard about agentic AI, and typically when you think about agentic AI, you think about writing a software program that uses the Chat GPT or the Claude or the Google Gemini API, right? So the average person is not going to do that. The average person is not going to sit there and put together a software program, purchase API tokens and API keys from these AI companies just so that they can use agents. But if you can incorporate agents into the web user interface, into the visual AI that people access, that the majority of people access, then that's something different altogether. That is more turnkey, and that is something that, if there's some possibilities there to have an agent that can work on your behalf, then that could be a huge game changer. So he's using it for business, but imagine if You could use the same concepts he's describing here for other things like administrative work, for putting reports together, for tracking metrics in a business, whether that be sales or accounting or customer service or manufacturing, you name it. There are many possibilities here. For personal use, maybe you just want to understand current events better. And rather than just simply use the web search feature of, let's say in this example, ChatGPT, you could basically have the agent take its time and gather for you and put in the right format for you what is the best synopsis of the present current events, right? And you could do that so easily, right? So it's not some elaborate, complicated thing, and you could do that so easily. So when you're trying to understand, so if you're a person that tries to understand things, but if you could save time where previously you'd have to spend 3 or 4 hours reading a series of web articles. You'd have to spend several hours reading some books. You'd still have to read, but imagine if you could get a lot more information in a more condensed form where you could understand the most important aspects of all the things that are out there that you are interested in, and you could use an AI agent to do that. So then I was like, whoa, there are some things that you could do in software development with these agents. The way that OpenAI has presented here with the agents that he's demonstrating here, if you were to apply that to software development, there are some major things that you could do with that. So, one of the things that I noticed here.
Once, I'm going to ask it to do this. Make a list of 5 dentists in Austin, owners only. Write 5 cold emails that are hyper-personalized to each of them. Also, almost creepily, stalkerish personalized. Tell them I offer SEO services only for dentists in Austin and would love to hop on a call with them. All right, it's going. All right, let's see if we can have 4 running at the same time. So I'm going to ask it to analyze Google Trends for 5 business ideas. Check.
So I encourage you to watch his video, but there is an aspect of his video that has not been discussed. This new agent capability can integrate with your Gmail, Google Docs, Sheets, Slides, right? And by doing that, see, it can write emails for you. So if you need to send, 40 emails and do this in an automated fashion, it can do that for you, right? I used to write programs for businesses that did that, right? This agent can do that just with a few clicks. Very smooth. But that's not the most important aspect of this that I'm seeing from a corporate software acquisition standpoint. Many people invest in Microsoft 365 to get certain efficiencies using a cloud-based version of Office, as well as Outlook. Microsoft is a partner with OpenAI, but OpenAI partnered with Google and their Gmail and G Suite, right? And in a sense, Google Enterprise. And the way that ChatGPT can automate your use of Gmail and the Google Docs tools is superior to what you get from Microsoft 365. And prior to the release of ChatGPT 5, OpenAI had already released a tool set that it can do data analysis, charting, and data science in such a way where it can replace many of the uses of Microsoft Excel. Someone estimated that approximately 25 million Microsoft Excel users who may be power users or on some spectrum of power user, the AI capabilities now makes their skill set obsolete. So there are many office level administrative functions tied to Microsoft Excel that this ChatGPT setup in particular now eliminates and streamlines. And then to have that potentially funneled into Gmail and Google Sheets, right? And then on top of that, you can do some other things as a software developer with the Google Docs APIs and all of that kind of thing. Then that poses a significant challenge to Microsoft. That poses a significant challenge to Microsoft. So I just wanted to touch on that. That was the only real thing I wanted to touch on that. And
imagine being able to build an app with your name on it just by thinking about it.
Boy, you gotta love these
Base
ads, right?
44.
Skip that.
All right, let's see what it does
So-
now that it's in my email. It's interesting. It says, watch while ChatGPT works with sensitive data. ChatGPT is working with mail.google.com, which contains sensitive data. If you notice anything bad happening, you can stop the task. That's them trying to cover their butt. They don't want to be liable for anything that happens. All right, let's check out my energy drink competitor research here. All right, common complaints from Amazon reviews and expert articles.
It is very comprehensive what you are able to do with the agent capabilities here. And yes, you do have to be cognizant of security. So corporations, may decide to stay with Microsoft 365 so that they can mitigate some exposure, right? But there may be others who may get assurances from OpenAI as well as Google themselves that this type of integration has some security assurances that are not publicly disclosed. So, there are various ways to look at this. But on the whole, for those organizations, small businesses and startups and entrepreneurs, where this would be a valuable tool where they could be more competitive with larger organizations, or even organizations at their same level who do not take advantage of these tools, there are some significant possibilities here. So I just wanted to lay that out, and I hope you enjoyed this. And if you have any comments about this, then I welcome those comments. It does take me some time to respond to comments, depending on what's going on in a given week. But I always make it my plan to respond to comments over the course of time. And I'm going to put up some, stuff about, other topics that are related to this. And these will help those that are new to this see what's going on in the total picture. I'm going to put up the video from 2 years ago where I explain how Google is probably going to be the long-term victor in AI. I'm also going to put up a more recent discussion that I had about AI, and as far as how you get better quality with AI. And I'm also going to put up some information about Linux and maybe one other topic. So thank you again for tuning into this. And if you have any questions about how to make your AI work better for you, how to get better quality out of AI, understand that what I am really saying now is that we are past the point of being AI naysayers. We're past the point of saying that this AI isn't going to work. We're past the point of saying that, the AI bubble is going to pop and burst and all this is just going to be a distant memory. We're way past that. Yes, some companies may actually fail because the way that they are approaching AI just doesn't work for society at this moment. But the actual tool itself, has now been proven as a legitimate tool, especially when you look at my other video about this, where I talk about AI quality and how all those that now talk about how AI flops and AI doesn't work and this or that, there's either some significant bias there, or there is just something there that where it's like they just did not explore deeply enough to really find out the truth. And so with that, this discussion was not meant to be offensive to anyone. It was truly not meant to be offensive to anyone. I approached this in a good spirit, where I'm looking at the quality of software development. I'm looking at the continued primacy of software development mastery at the individual human level, and how it is very clear that you need humans to build AI, and AI that is marketed as anything other than a tool that helps people do what they do better is, for the most part, going in the wrong direction. And the exceptions to that would be things like online chatbots for e-commerce or customer service, and anything where you need to just write generic documents that needs to be mass emailed or mass distributed by text or other mechanisms. Those are areas where you would see AI cutting headcount in a legitimate way, where it's routine, documentation centric, and verbal centric type of tasks. But for other areas where you really need that integration between the subjective preferences of humans and the technical or procedural expertise to produce something that fits to that situation, where it cannot be routinely done in its entirety without oversight and involvement of quality assurance, QA, and others like that, then we see that AI replacing everybody is not entirely accurate. So, yes, again, thank you for tuning in, and I will see you later.